In this video, we're going over contains duplicate 3. So give an integer array nums and two integers k and t. Return true if there are two distinct indices I and j in the array such that the absolute difference between the elements at the two indices is less than or equal to t, and also the absolute difference between the two indices is less than or equal to k. In our first example, we're given this array 1, 2, 3, 1. You can see that the elements at index 0 and 3 has an absolute difference, which is less than or equal to t, 0. And also the difference between the two indices is 3 minus 0, which is less than or equal to our k value, 3. So we return true. Let's go with the dot process. So for each of the elements, x at index I, we will want to search for an element, y, from indices I minus k to I minus 1. Now, what is the value of y? We will want y to be as close to x as possible. This is because the absolute difference between x minus y is less than or equal to t. So we want y to be as close to x as possible. This means y can be the smallest value that is greater than x, or the largest value that is smaller than x. Now this will mean we will need a quick way to find the ceiling and floor of x. Now the ceiling just means the smallest value that's greater than x, and the floor just means the largest value that's smaller than x. Now we can create a tree set to allow us to quickly find the ceiling and the floor. And the floor in log time complexity. Now let's go over the pseudocode. So we're going to create a tree set to keep track of previously seen elements. Now we're going to iterate through the indices of the input array, denoted as I. We're going to retrieve the current elements x at index I. Now I want to find the ceiling of x from this set. Now if ceiling is not null, this means the ceiling exists. And the absolute difference between ceiling minus x is less than or equal to t, we can return true. Now I want to find the floor of x from the set. If floor is not null, this means the floor exists. And the absolute difference between x minus the floor is less than or equal to t, we can return true. Now we'll add x to our set. Now if set.size is greater than k, we want to remove the elements at the leftmost side because we have went out of our boundary, because our boundary has to be from I minus k to I minus 1. So we're going to remove the elements from index elements nums I minus k from set. Now we'll return false if we have failed to find a pair. Now let's go over the time and space complexity. For the time complexity, we get O of n log k, where n is the total number of elements, and k is the input value. So we visit each index once and operate on our tree set. This is because we have log of k, because in our tree sets, the largest number of elements is k. In our space complexity, we get O of k, where k is the input value. This is because of our tree set. Now let's go over the code. So we're going to create a tree set. Then we're going to iterate through the indices of the input array. We're going to retrieve the current element x at the current index. Now I want to find the ceiling of x, which is the smallest elements that's greater than x. If ceiling is not null, it's not equal to null, and the absolute difference between, we need to cast the ceiling to long. Ceiling minus x is less than or equal to t will return true. We need to cast this to long because ceiling can be a very large value and x can be a very small value which will overflow. For example, if ceiling is 2 billion and our current x value is negative 2 billion, it will cause an overflow, which will get us 4 billion, which means it will cause an overflow because the maximum value inside an integer is around 2.1 billion. Now integer floor, now we'll want to find the floor of x. Now if floor is not equal to null and the absolute value between x minus casting floor to long is less than or equal to t will return true. In this case, we're casting floor to long because in the same case as above, it may cause an overflow. Now I want to add x to our set. Now if set.size is greater than k, we have went out of our range. So we want to remove the element that's currently on the rightmost side or the leftmost side. Now we'll return false if we have failed to find a pair. Actually, this is floor. This is floor. Let me know if you have any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview.